These are the last three problems that you'll see on Algebra A's study guide for Test 2, Quarter 3. And so the last three problems are going to ask us to solve systems of equations. And actually the last one we could write as a system as well. And so we'll end up doing that. And so let's take a look at this first one here. Well, this is a great one for substitution. Remember, there's two methods, and we get to use both methods today. Substitution is a great method when a variable is by itself. And so here I'm going to end up using this substitution method, and that's when I take what x is, or sometimes we have y equals an expression, but this time x equals an expression. I'm going to take what x is, and I'm going to substitute it in place of the x in the equation below. But we got to be careful with this one here, because when we do this, we're going to end up writing that expression, 3, but then I've got to put parentheses around this expression that x is. See, x is y minus 4, and parentheses need to go around it because what's happening here is 3, or x, is being tripled in this second equation. So I'm multiplying 3 by what x is, y minus 4. And then I rewrite the rest of the equation. So you see I highlighted in blue what I put in place of x in that second equation. So we go ahead and use the distributive property here, multiply 3 over that subtraction. And what's left over? Well, we've got 3y minus 12 minus a 2y equals negative 7. So a common mistake I'm going to see people make is they're going to add the opposite for the y's, but that's not what we do. See how the y's are on the same side of this equal sign? So here I collect the two y values. So I'm adding them together, and that ends up just making a 1y. I end up having to subtract because they're opposite in sign. One's positive, one's negative. But over here, how the 12 is on the opposite side of the equal sign, this is where I'm using opposite operations. So I'm left with y on the left-hand side, and this all equals 5 on the right, because negative 7 plus 12, opposite signs, so I subtracted. So y is 5, but we're not done. We still need to solve for x. So I'm going to take this 5, and I'm substituting it back in for one of the y's in one of the equations. I'm going to pick that first equation because it seems easier. X equals y, but in place of y, I'm putting 5 minus 4, and I end up with 1. So there's x. So x equals 1, y is 5. Write the answer as an ordered pair. 1 comma 5 would be the answer. Well, the next problem right next to it that you're going to see is an elimination problem. So we're going to, or sometimes they call this the addition method, like you're adding the two equations, but I'll go ahead and write down elimination. So that's the method I'm using. And why do I use it? Well, I don't have y or x by itself, and I've got the x's and y's and equal signs and constants all lined up. So this method's a little bit faster. That's why I'm going with it. Well, what I'm going to do is I'm going to take this second equation, and I want to eliminate the y's. That's going to be the easiest one to eliminate. So I'm going to multiply that equation by 3. The trouble is most kids that make the mistake here will end up just multiplying the y by 3. You got to multiply every number by 3 here. So let's go ahead and rewrite what we've got. Well, that first equation is going to stay the same. 2x plus 3y equals 12. But the next equation is going to become 5x minus 3y, because it's already a minus sign. And oops, I made a mistake. Not 5x, 15x. I did what most kids would end up making the mistake of, is not changing that first number or the last. So 3 times 5 is 15x minus 3y equals 39. And so from there, you just add this together. And so when I add these equations, let's see what ends up happening here. Well, the y's end up canceling because they're opposite sign. But we end up having to add these numbers together. We get 17x equals, and this makes 51. Remember, you got to carry a 1 up here. 2 and 9 make 11. Carry a 1 and makes 51. So from there, I go ahead and do some division. And 17 does go in there evenly. Think of 7 times what makes a 1 at the end. I'll try 3, and it does end up working. 3 times 17 does make 51. So we've got what x is. Now we do the same thing we did on the last problem. We substitute. The substitute is going to be a little bit trickier because you got more numbers to deal with. So I'm going to end up putting it in place of, well, let's try this x right here. So I'll put that x, that 3, right in place of that x. So it's now I rewrite 5, but in place of x, I'm writing 3, and then minus y equals 13. So I go ahead and do that work. That makes 15 minus y equals 13. So I've got to subtract that 15 from both sides. And then I end up with a negative y, or the opposite of y equals negative 2. Well, you still need to get rid of that negative sign. So some people will forget to do this. You got to divide by that negative 1. And so y equals positive 2, because the negatives will end up canceling. So write your answer as an ordered pair. 3, 2 gives you your answer. Well, the next equation is a system as well. We can write a system for this because we'll end up with 2 unknowns. Let's read what it says. Ann bought 3 CDs and 1 DVD for $20. Joe bought 2 CDs and 2 DVDs for $24. Find the cost of a CD and a DVD. Well, I don't know. Those are the questions. So those are 2 unknowns. So they want to find 2 things. So let's do this. Let's call C the cost of a CD, D the cost of a DVD, and let's write an equation. So let's write Ann's equation. We'll write hers first. Ann, well, her equation, 3 CDs, 3 times the cost of a CD, and 1 DVD, so plus 1 DVD. And that cost was $20. So 3 CDs, 3 times the cost of the CDs, plus 1 times the cost of the DVDs, totaled $20. Well, that's Ann's equation. Joe's equation. Well, Joe had 2 CDs, so 2 times the cost of a CD, plus 2 DVDs. 2 times the cost of a DVD equals $24. And so now we're ready to solve. See, we can set up an elimination problem here because the C's, the D's, the equal signs, and the constants are all in line. So another elimination problem is what I'm going to end up doing here. So I'm going to go ahead and multiply this top equation by negative 2 because I want to cancel out the D's. And so I multiply every number there by negative 2, and I end up with a negative 6C minus 2D equals negative 40. Negative 40. I got to multiply those numbers. And so I go ahead and add this stuff together. Now when I add this, I end up canceling out the D's, and that's okay because we want to only have 1 unknown left over so we can end up coming up with an answer. And so for the 1 unknown. And so I end up with a negative 4C equals, and then I do the subtraction. Make sure you put the bigger number on top if you don't have a calculator, because you might end up making a subtraction error and calling it 26 or 24 or something like that. So let's see what we end up doing. You have to borrow from the 4, change it to a 3, and we end up with 16 rather than 24 or whatever other kids will end up with. Now, is it positive or negative? Look, we got more negatives than we have positives. So we'll put a minus sign right there. And so we go ahead and do the division, and right away you'll see how we end up canceling out those negatives, and that's always a good thing. So we don't want to have to pay the store to pay us for getting a CD, so we want to pay the store. So C is 4, so the CDs cost $4. Well, how much do the DVDs cost? Just plug that 4 back into one of these equations. I'm going to go ahead and pick this one right here. So put it right in for that Ann's equation, I guess. 3 times C, but in place of C we're putting 4, plus a DVD equals 20. So $12 was the cost of the CDs for Ann, and we want to find out how much the DVD is. You just got to subtract that 12 from the total cost that she ended up paying, which was $20, and that gives us $8 for the DVD. So there it is, $8 for the DVD, and we have $4 for the CD. And there we have it. So that's the problems you'll see on this week's test. Good luck.